we highly recommend checking out Mindful Moments.
Absolutely.
It's like a personal pocket philosopher offering bite-sized insights from great thinkers delivered through the magic of AI narration.
It's a great resource.
It's perfect for those moments when you need a little mental nourishment on the go.
Yeah.
We always talk about like how adaptable our minds are, right? Learning new things, growing from experience. But what if we're thinking about it all wrong? What if our minds aren't exactly a blank slate?
Yeah, there's this idea that maybe we're born with a lot more already built in, like a really complex operating system with all these programs ready to go.
Right, kind of like preloaded software. And that's what we're looking at today, how our minds are designed. And we're going to go deep looking at all these ideas about how we might actually have all these pre-wired systems shaping our thoughts.
It's a big topic for sure, trying to figure out this whole system of how our minds work. And, the more you think about it, the more you realize just how much is going on up there.
Absolutely. It's pretty mind-blowing when you look at, the simple stuff we do every day with our minds, and then you think about how hard it is to get a computer to do the same things. It really makes you appreciate what we've got.
Yeah, like building a robot that can actually think and act like a person, it's so much harder than it seems.
Right. And some things about our minds, well, they're still a total mystery. But other things, well, science is starting to give us some answers.
And we're going to cover those today. We'll be talking about some really important ideas that are changing how we understand our minds. Stuff like how the mind works like a computer, how our brains have all these specialized parts, how evolution has shaped our thoughts and feelings, and even how our brains store information.
The big goal here is to give you a new way to think about your own mind. Help you understand why you think and feel and act the way you do.
Yeah, like giving you a peek behind the curtain to see all the amazing stuff that's happening in your head all the time.
I love that analogy. And I think a good place to start is with something that seems super simple, like when a little kid follows instructions.
Okay, I see what you mean. Like imagine a 4-year-old, you ask them to put their toys away.
Right. On the surface, it doesn't seem like that big of a deal. But when you really think about it, it's actually a bunch of complicated processes happening all at once.
Yeah, I mean, try programming a robot to do that.
Right.
To understand what you're asking and then actually do it just as smoothly and naturally as a kid does, it's a nightmare.
Seriously. And this is where things get interesting. The reason AI is so hard to get right isn't because we're bad at building AI. It's because our own brains are way more sophisticated than we give them credit for. All those things we take for granted, like seeing, understanding language, figuring out what to do next, it's all way more complex than launching a rocket.
Exactly. And it's worth taking a minute to appreciate just how amazing our minds are. We're walking around doing all these incredible things every day.
We are. So how do we start to understand all this complexity?
Well, one of the big ideas is this thing called reverse engineering the psyche, which basically means trying to figure out how the mind works by working backward from what it can do.
Okay, like taking something apart to see how it's built.
Mhm.
And what does that tell us?
It tells us that our minds are kind of like a toolbox with all these specialized tools for solving different problems.
Like mental tools.
Exactly. But not just random tools. These tools have been shaped over thousands of years by evolution. Like, they helped our ancestors survive and pass on their genes.
So these tools were designed to solve the kinds of problems that people faced way back then.
Right. Things like finding food and shelter, avoiding danger, understanding other people, all the things you need to do to stay alive and have kids.
Makes sense. So we've got these mental tools.
Yeah.
But how do they actually work? Like, one thing that's always confused me is how something like a belief or a desire, something you can't even see or touch, can make you do something in the real world.
Ah, you're talking about the mind-body problem.
All right.
How can something intangible have a physical effect?
Exactly. Like, how does wanting a cup of coffee actually make me get up and make one?
Okay, so the computational theory of mind offers an explanation. It says that beliefs and desires are actually information that's encoded in the physical structure of our brains.
So you're saying that my brain stores information about what I believe and what I want, and that this information is somehow stored in the connections between my neurons.
Right, like think of it like a musical score. The music itself isn't in the ink on the page, it's in the patterns and the relationships between the notes.
I see. The paper and ink are just the physical stuff, but the music is something more than that.
Exactly. And it's the same with our brains. It's not just the individual neurons that matter, it's how they're connected and how they fire together. That's where the meaning is.
So my brain is like a symphony orchestra, and my thoughts and desires are the music.
That's a pretty good way to think about it. And to understand the brain, you need to understand the music it's playing, not just the instruments.
So we're talking about software and hardware again. Our brains are the hardware, and our thoughts and feelings are the software.
Right. And to take that analogy further, it's like our brains aren't just one big computer. It's more like they're made up of lots of smaller, specialized computers all working together.
Which brings us to the idea of mental modules.
Exactly. The idea is that our minds are organized into these modules, kind of like mental organs. Each module is specialized for a particular kind of task. Like there's a module for language, a module for recognizing faces, a module for understanding physical objects, and so on.
So it's like a team of experts, each with their own area of expertise.
That's a good way to put it. And the cool thing is that most of the basic wiring for these modules is already there when we're born, thanks to evolution.
So these modules have been shaped by natural selection over millions of years to do specific jobs that helped our ancestors survive. Can you give an example of how one of these modules might work?
Okay, well, take our ability to see surfaces. We have this special surface perception module in our brains, and it's amazing at figuring out what we're looking at under normal conditions, like in daylight.
So it helps us navigate the world and interact with objects.
Exactly, but it's so specialized that it can be fooled sometimes.
How do you mean fooled?
Well, this module is based on certain assumptions about how the world works. Like, it assumes that light comes from above and that surfaces are usually smooth. But those assumptions aren't always true.
Right, like when we're watching a movie, we know it's not real, but it still looks three-dimensional because our brains are making those assumptions.
Yeah. And stage magicians use those same tricks to create illusions. They're basically hacking our surface perception module.
So our brains have these built-in shortcuts that are usually helpful, but sometimes they lead us astray.
Exactly. And those shortcuts are there because of evolution. They were helpful for our ancestors, even if they're not always helpful for us today.
So this idea that evolution shaped our minds, it's not just about physical traits like our thumbs or our eyes, it's about our thoughts and feelings too.
Yeah, and that can be a hard pill to swallow for some people.
Why is that?
Well, I think there are a couple of reasons. First, sometimes people try to explain behavior with evolution before they've even figured out what the behavior really is. Or they'll try to explain something complex by assuming something else is true without explaining that. Like,
No.
if you say, well, people are drawn to happy people because it helped their ancestors survive, you have to explain why being drawn to happy people was good for survival.
You can't just assume it. You have to show how it actually works.
Exactly. And second, people sometimes forget that evolution isn't about making things perfect. It's about making things good enough to survive and reproduce. So not every thought or feeling we have is going to be a direct adaptation.
Right, so things like art and music and philosophy, maybe they're not direct adaptations in the sense that they don't directly help us survive.
Right. But they might be byproducts of other adaptations. Or they might be new things that our evolved minds are able to do, even though they weren't directly selected for.
It's like our minds are powerful enough to do things that go beyond what evolution intended.
I like that. And then there's the whole nature versus nurture debate. Some people think that everything about us is determined by our genes, but that's not true.
Right. Our genes provide the blueprint, but our environment and our experiences shape how that blueprint unfolds.
Exactly. And studies on twins and adopted kids have shown that genes are important, but they mostly explain how we're different from each other, not the basic stuff that makes us all human.
It's like genes determine whether we'll be tall or short, but they don't determine whether we'll be able to walk.
That's a good way to put it. And we have to be careful about oversimplifying the role of genes. Like, you can't just point to a single gene and say, that's the gene for violence or whatever. It's way more complicated than that.
So we've got these mental modules, we've got evolution shaping our minds, but how does all this translate into our actual experience of the world?
That's where mental representations come in. Mental representations are the way our minds store and process information about the world.
So like mental pictures or something.
Well, it can be like that, but it's more general than that. Like, think about how you can recognize the letter A in all sorts of different fonts.
Right. It doesn't matter if it's printed or handwritten, uppercase or lowercase, I still know it's an A.
Exactly. That's because your brain has an abstract representation of A that isn't tied to any specific visual form.
So it's like a concept of A that exists in my mind,
Yeah.
separate from any particular image of an A.
Right. And that's just one type of mental representation. We also have representations for sounds, for grammar, for concepts, and so on.
And these representations are what allow us to think and reason about the world.
Exactly. They're the building blocks of our thoughts. And they come in different formats. We have visual imagery, which lets us picture things in our minds. We have phonological representations, which are about the sounds of words. Grammatical representations help us understand the structure of sentences. And then there's this thing called mentalese, which is like the language of thought.
Mentalese, that sounds intriguing. What's that?
Well, it's kind of a hypothetical language that our brains use to represent thoughts. Like, when you understand a complex idea, you're not just memorizing the words you heard. You're creating a representation of that idea in your mind using mentalese.
So mentalese is like a universal language that all the different parts of my brain can understand.
Yeah, that's the idea. It's how the different modules communicate with each other.
That makes sense. So we have all these representations, but how does the brain actually learn and reason with them?
Well, one way to think about it is with neural networks. Neural networks are kind of like simplified models of how neurons connect and interact in the brain.
So they're like computer programs that try to mimic how the brain works.
Yeah, and they're really good at learning from experience. Like, you can train a neural network to recognize faces or to translate languages.
And they're good at dealing with messy information, right? Like if a picture is blurry or a sound is muffled, they can still figure out what's going on.
Exactly. That's called graceful degradation. It means that they can still function even when the input is imperfect, just like our brains can.
That's pretty cool. But just forming connections between different pieces of information isn't enough for real understanding, is it? Like just knowing that cat goes with meow and dog goes with bark doesn't mean you really understand what a cat or a dog is.
Right. You need more than just associations. You need to understand the relationships between concepts. Like, you need to understand that a cat is a type of animal and that animals have certain properties that distinguish them from other things.
So we need more than just simple learning. We need something like rules or theories that help us organize our knowledge.
Yeah. We develop these things called intuitive theories about how the world works. They're like mental models that help us make sense of things.
So if I see a creature with feathers and wings, my intuitive theory about birds tells me that it's probably a bird, even if I've never seen that particular type of bird before.
Exactly. And these intuitive theories are super powerful. They allow us to go beyond the information we're given and make predictions about the world.
So our minds are constantly building these models of the world based on our experiences and our innate knowledge. And then we use those models to guide our actions.
Yeah, it's a pretty amazing system.
It is. Now let's shift gears a bit and talk about how we actually experience the world through our senses. Like, how does our mind's eye work?
Ah, that's a great question, and one that's been debated for centuries. Like, are our mental images really like pictures in our heads, or are they more like descriptions?
I'm not sure I understand the difference.
Well, a picture is a visual representation of something, but a description is more abstract. It uses words or symbols to represent something.
Okay, so if I'm imagining a beach, is my mental image a picture of the beach, or is it more like a list of features like sand, water, waves, and so on?
That's the question. And there's evidence to support both views.
Oh, so we don't really know for sure.
Not yet. But what we do know is that our visual system creates a really detailed three-dimensional representation of the world.
Okay, but we see the world with two eyes,
Mm-hmm.
right? How does our brain combine those two images into a single view?
It's called the correspondence problem. Our brain has to figure out which parts of the two images match up. And it does this using a bunch of cues, like the differences in the angles of the two images.
It's like a puzzle, isn't it?
It is. And it's a puzzle that our brains solve constantly without us even realizing it. And the solution to that puzzle gives us depth perception, which allows us to see how far away things are.
Oh, wow. So our brains are constantly doing all this complex math just to make sense of the world.
Yeah. And it's not just depth perception. Our brains are also making a bunch of other assumptions about the world to help us make sense of what we see. Like, they assume that light comes from above, which helps us interpret shadows.
Right. And those assumptions are usually right. But they can also be tricked, which is how camouflage works.
Exactly. Animals that are camouflaged are basically exploiting our brain's assumptions about how light and shadow work to make themselves harder to see.
That's so cool. And then there's the fact that the image on our retina is constantly changing as we move our heads and our eyes, but we still perceive objects as stable and unchanging.
Right. That's object constancy. And it's another example of how our brains are constantly working to create a stable perception of the world.
So even something as simple as seeing is actually super complex.
It really is. And all of this complexity is the result of millions of years of evolution. Our visual systems have been honed over time to solve the specific challenges that our ancestors faced.
It's pretty mind-blowing. Okay, Now let's move beyond vision. What about our understanding of the physical world, like how objects move and interact?
Well, we have this thing called intuitive physics. It's a set of basic principles about how the physical world works that we seem to be born with.
Like,
Like, we know that objects can't just disappear or appear out of thin air. We know that solid objects can't pass through each other. We know that things fall down when you drop them.
yeah, that all seems pretty obvious.
It does, but these are actually really important principles, and babies as young as a few months old seem to understand them.
Really? How do they know that?
Researchers can test this by showing babies unexpected events.
Yeah.
Like, they might show a baby a ball rolling behind a screen, and then the screen is lifted and there's no ball.
And the babies are surprised.
Yeah. They stare longer at the impossible event, which suggests that they expected the ball to still be there.
Wow. That means that our understanding of the physical world starts developing really early.
It does, and it's not just about physics. We also seem to have innate intuitions about different categories of things in the world. Like,
Yeah.
we know that animals are different from plants and that both are different from rocks.
Right, so it's like we're born with a basic understanding of how to categorize the world.
Yeah, and that's really helpful for learning because it gives us a starting point. It means we don't have to learn everything from scratch.
I see. So we're born with these basic intuitions about the world, but we also develop more complex reasoning abilities as we get older. What about logic? Do we use logic in our everyday lives?
We do, but not in the same way that a computer uses logic.
What do you mean?
Well, computers use formal logic. They follow a set of strict rules to make deductions. But humans are more flexible. We use our intuitions, our emotions, and our experiences to guide our reasoning.
So it's not like we're always thinking in syllogisms.
No, our thinking is much messier than that, but that doesn't mean it's irrational.
So even though we don't always follow formal logic, our reasoning is still generally sound.
Yeah. We're good at making judgments and decisions based on incomplete information, and we're pretty good at detecting patterns and making predictions.
And those abilities are probably what helped our ancestors survive.
Exactly. Our reasoning abilities evolved to help us deal with the real world, not with abstract logical puzzles.
Makes sense. Okay, so we've got these mental modules. We've got evolution shaping our minds. We've got mental representations. We've got intuitive physics. And we've got some kind of messy but effective logical reasoning abilities. What else is there?
Well, we haven't talked about language yet.
Oh, right. Language is a big one. It's what sets us apart from other animals.
It is, and it's incredibly complex. But even language seems to be built on top of these more fundamental cognitive abilities.
Like what?
Well, for one thing, a lot of our abstract concepts are based on metaphors that come from our physical experience of the world. Like, we talk about grasping an idea or being weighed down by problems.
Right, those just metaphors. But they feel really natural.
They do, and that's because they're tapping into these deep-seated intuitions that we have about the world. Like, our brains are wired to understand things in terms of space and force, and so we use those same concepts to understand abstract ideas.
So even though language is this incredibly complex thing, it's still grounded in our basic understanding of the physical world.
Yeah, and that's true of a lot of our cognitive abilities. They're built on top of these more fundamental building blocks.
So our minds are kind of like these incredible towers that have been built up over millions of years of evolution.
I like that analogy.
Okay. Now, let's talk about emotions. Emotions are another thing that seem really personal and subjective, but they're also shaped by our biology, aren't they?
They are, and there's a growing understanding that emotions aren't just these random things that happen to us. They're actually really sophisticated adaptations that have evolved to help us survive and reproduce.
So they're not irrational.
Not necessarily. They might not always be helpful in our modern world, but they were probably helpful for our ancestors.
So like fear would have helped our ancestors avoid danger, and anger would have helped them defend themselves.
Exactly. And even emotions like love and sadness probably served important evolutionary functions.
Like love would have helped us form strong bonds with our mates and our children, and sadness would have helped us cope with loss.
Yeah, so even though emotions can sometimes be unpleasant, they're actually really important for our well-being.
But how do we know that emotions are really adaptations?
Well, for one thing, basic emotions like happiness, sadness, anger, fear, disgust, and surprise seem to be universal.
You mean people all over the world experience them.
Exactly. And that suggests that they have a biological basis. It's not just that different cultures have learned to express these emotions in different ways, it's that the emotions themselves are innate.
And we see evidence of emotions in other animals too, right?
We do, which suggests that emotions are a very old adaptation, something that evolved long before humans even existed.
Okay, so emotions are adaptations, but how do they actually work? Like, what's going on in the brain when we feel an emotion?
Well, there are a lot of different brain areas involved in processing emotions, but one key area is the amygdala.
The amygdala.
Yeah, it's a small almond-shaped structure deep inside the brain, and it's responsible for detecting threats and triggering fear responses.
So it's like the brain's alarm system.
Yeah, and it can trigger those fear responses really quickly without us even having time to think about it.
Like if we see a snake or a spider.
Exactly. But the amygdala isn't just about fear, it also plays a role in other emotions, like anger and happiness.
So it's a pretty important part of the brain when it comes to emotions.
It is. And it's just one part of a complex network of brain areas that work together to produce our emotional experiences.
It's really amazing how all these different parts of the brain come together to create something as complex as an emotion.
It is. And it's another example of how evolution has shaped our minds to deal with the challenges of life.
Okay, so we've talked about how our brains are structured, how they process information, how they learn, how they reason, and how they generate emotions. Now let's talk about social interactions.
Okay.
Social interactions are obviously a huge part of human life, and there's a growing body of research that's looking at how evolution has shaped our social brains.
Right. Like one interesting finding is that humans seem to have an innate preference for certain kinds of landscapes.
What kind of landscapes?
Landscapes that resemble the savanna. You know, open grasslands with scattered trees.
Oh, like the environments where our ancestors evolved?
Exactly. And researchers think that this preference might be an adaptation. Like, savannas provided good visibility for spotting predators and prey, and they also had a lot of resources, like food and water.
So our brains are still wired to prefer those kinds of environments, even though most of us don't live in savannas anymore.
That's the idea. And there are other examples of how evolution has shaped our social preferences. Like, we seem to be predisposed to fear certain kinds of animals, like snakes and spiders.
Because they were dangerous to our ancestors.
Right. And we also seem to be hardwired to pay attention to social status.
What do you mean?
Well, we're constantly comparing ourselves to others. We want to know where we stand in the social hierarchy, and that's probably because social status was really important for our ancestors.
Like, if you were high status, you had more access to resources and mates.
Exactly. So our brains are still attuned to those kinds of cues, even though they might not be as important for survival in our modern world.
So we're walking around with these ancient brains that are still trying to make sense of the world in terms of predators and prey and social status.
That's right. And that can lead to some interesting conflicts, like our brains are wired to seek out sugary and fatty foods because those foods were scarce and valuable for our ancestors. But in our modern world, those foods are everywhere, and that can lead to obesity and other health problems.
So it's like our brains haven't caught up to our modern environment.
Yeah. And that's true of a lot of our social behaviors, too. Like, we're wired for cooperation and altruism, but we're also wired for competition and aggression.
So which one wins out?
Well, it depends on the situation. But one thing that's really interesting is that we seem to be really good at detecting cheaters.
Cheaters, like people who break the rules.
Yeah. Like, if someone promises to do something and then they don't follow through, our brains are really good at picking up on that.
Why is that?
Well, because cooperation is really important for human survival. And if you're cooperating with someone, you need to be able to trust that they're going to hold up their end of the bargain.
So our brains are wired to detect people who might take advantage of us.
Exactly. And that's probably why we have such strong emotions about fairness.
It's like we're programmed to care about justice.
In a way, we are. And that sense of justice is probably what underlies a lot of our moral intuitions.
So our social brains are complex. They're wired for both cooperation and competition. And they're really good at detecting cheaters.
Yeah. And all of that complexity is the result of millions of years of evolution.
Now, with all this in mind, think about all the ways we interact with information these days. We read books, we watch movies, we scroll through social media, we listen to podcasts, and all of that information is being processed by these incredible brains that have evolved over millions of years. It's really amazing when you think about it.
It is.
And it's even more amazing when you consider that there are now AI systems that are starting to be able to do some of the same things that our brains can do. Like there are AI systems that can recognize faces, translate languages, and even write poetry.
Yeah. And one really cool example of this is a YouTube channel called Mindful Moments.
Mindful moments. What's that?
It's a channel that uses AI to analyze audiobooks. Like, it can identify the key themes and insights from a book, and it can even create summaries of the book.
So it's like having an AI study buddy that can help you understand complex information.
Yeah, that's a good way to put it. And the fact that AI is able to do this kind of analysis is a testament to the power of our own cognitive abilities.
It's like we're starting to understand the secrets of our own minds by building machines that can think like us.
Exactly.
So let's wrap things up. We've covered a lot of ground today, but what are the key takeaways?
Well, I think the biggest takeaway is that our minds are not blank slates. We're born with a lot of innate knowledge and abilities, and those abilities have been shaped by millions of years of evolution.
So we're not just products of our environment, we're also products of our evolutionary history.
Right, and that means that we can't fully understand ourselves without understanding our evolutionary past.
And another key takeaway is that our minds are incredibly complex. They're made up of all these different modules that work together in ways that we're only just beginning to understand.
Yeah. And even the simplest mental tasks, like recognizing a face or understanding a sentence, involve complex interplay of different brain areas.
So our minds are these amazing machines that we're still trying to figure out.
Exactly. And that's what makes studying the mind so fascinating.
It really is. Okay, one last question. If our minds evolved to solve the problems of our ancestors, how well equipped are we to deal with the challenges of the modern world? Like, our ancestors didn't have to deal with things like climate change, nuclear weapons, or the internet.
That's a great question. And it's one that I don't think we have a good answer to yet.
It's a little scary, isn't it?
It can be, but it's also exciting because it means that there's still so much to learn about ourselves.
Well, I think that's a great place to end our deep dive. If you enjoyed this episode, please subscribe to our channel for more deep dives into fascinating topics. And if you'd like to learn more about the ideas we discussed today, you can find links to some great books and articles in the show notes.
And be sure to share this episode with anyone you think might be interested.
And remember, always think critically about the information you encounter. Until next time.